Hello, welcome back to Algebra 1. We're going to be talking about functions for quite a long time, and we've actually been evaluating functions in a basic way up until now, but we're going to go through several examples of evaluating functions just to give you a little more practice with it. The basic idea is when you evaluate a function, you just plug in the value for the input and you calculate the value on the output. That's all you're doing. So let's start with an easy, very simple example. What about the function f of x equals 5x minus 9. This means I have a function of x, so I stick a value of x in here and I calculate an output. So what if, for instance, I want to evaluate, we call it evaluating a function when you plug in a specific value at x is equal to 3. When we stick the 3 in here, we're basically saying x is equal to 3, what happens? So we stick that value in here and we calculate 5 times 3 minus 9. All right, so 5 times 3, as you know, is 15 minus 9, and 15 minus 9 is going to be 6. So the way that you circle your answer is f of 3, and that's how you say it, f of 3, or f evaluated at x equals 3 is equal to 6. This is what you would calculate and write down as your final answer. So what you're saying is when you put a value of 3 in, you get a value of 6 out of that machine that we're calling a function here. We're just going to do several here to get your feet wet here. What if we have another function called h of a, I'll explain that in a second, equals 3a squared minus 2. Now most of the time when you're dealing with functions, we're going to be talking about functions of x. So whatever variable you see here, you're going to also see it here. But honestly, it doesn't really matter what variable you put here, as long as whatever you have in here for the variable is also in your function. So we're saying a function, we're naming it h, could be h for horse, maybe we're trying to calculate how heavy a horse is or something like that. And we're plugging in the value of a, so we need to have a function or a calculation defined in terms of a, which we have here. Now notice that this has an a squared, so this is not a line. This is going to be some parabola we'll talk about later. It'll be a curved shape that we'll talk about and show you how to graph later, but it's definitely not a line because it doesn't look like mx plus b. You have a square term here. But at the end of the day, let's say we want to calculate when a is equal to negative 5. How do we do that? Well, whatever you stick in here, you just put it into the value or the place where a is. So it's going to be 3 times negative 5, but this whole negative 5 is squared, so we'll put that there minus 2. So how do we calculate this? We have to do the squaring first. So 3 times, what is negative 5 times negative 5 is positive 25. And now we do the multiplication next. 3 times 25 is 75. You know what, let's go down here. 75 minus 2, what's 75 minus 2? 73. So to summarize, h evaluated at negative 5 is equal to 73. This is the final answer. So for each of these, that's all we're going to do. We're just giving you exposure to different functions. What about something crazy? R is a function of y equals y cubed plus 8. Again, it doesn't really matter what the function's named. I could name this, pasta sauce. The letter doesn't matter. It's just basically you're saying, hey, we're going to name it something. Maybe I'm talking about raindrops. So I'm going to name this function R because I'm talking about raindrops. And it's a function of y. Y could be the size of the raindrop or something like this. And whatever I have here, I need to have some sort of equation on the other side or some sort of expression that involves that variable. Here I have y cubed plus 8. Now this is definitely not a line because it doesn't look like mx plus b, but it still can be a function. Now let's say that we want to evaluate this function at y is equal to negative 3. That means we stick the negative 3 in here. Negative 3